The Luftwaffe intelligence summary that reached Hermann Göring's Reich Air Ministry in Berlin during October 1944 contained aircraft production statistics that seemed to mock the fundamental laws of aviation manufacturing and aeronautical industrial capacity. The classified document claimed that American factories had delivered over 200,000 fighter aircraft since Pearl Harbor, suggesting production capabilities that violated every German assumption about precision aviation construction and wartime aircraft manufacturing limitations. This is aeronautical impossibility disguised as intelligence, Göring declared to his fighter command staff. Studying reconnaissance photographs of American aircraft factories that showed fighter production operations spanning multiple city districts. Fighter aircraft are precision flying machines requiring months of individual craftsmanship. No aviation industry possesses the manufacturing capacity to produce 200,000 advanced fighters. These Americans must be including training aircraft and civilian planes in their military production statistics. These were seasoned German aviation commanders who understood fighter production through decades of meticulous engineering and artisanal craftsmanship that had created the world's most sophisticated combat aircraft through systematic precision and technological excellence. The concept of mass-produced advanced fighters seemed to violate fundamental principles of aviation manufacturing that demanded individual attention over assembly speed. They could not comprehend they were witnessing the greatest fighter production achievement in aviation history, or that American factories would demonstrate how democratic industrial organization could manufacture combat aircraft at rates that would overwhelm German aviation excellence through unprecedented numerical superiority and continuous replacement capability that rendered individual pilot skill strategically irrelevant. If you want to discover more incredible stories of how American industrial supremacy revolutionized modern warfare, make sure to subscribe to our channel and hit that notification bell. Reichsmarschall Hermann Göring stood within the Messerschmitt production facility in Regensburg, embodying German confidence in aviation superiority through innovative aircraft design and systematic engineering excellence. As Supreme Commander of the Luftwaffe, Göring represented German assumptions about aircraft quality, triumphing over quantity through superior technology, individual fighter excellence, and professional aviation standards that had established German air dominance across European skies. German fighter aircraft production that Göring understood included meticulous craftsmanship, individual attention to aerodynamic specifications, and systematic quality control that created superior combat aircraft through careful engineering and performance optimization. German factories produced fighters like precision scientific instruments rather than mass-manufactured products, emphasizing technological excellence over production volume through artisanal manufacturing approaches that prioritized individual aircraft perfection. The sophisticated aircraft that German aviation employed included advanced Messerschmitt Bf-109s, revolutionary Focke-Wulf 190Hs, and jet-powered Me-262 SS that represented pinnacle achievements in fighter engineering through systematic development and operational experience. German engineering had solved complex aerodynamic challenges that produced aircraft exceeding Allied capabilities through individual excellence and precision manufacturing that emphasized superior performance over numerical abundance. Intelligence analysis of Allied fighter production suggested enemy forces remained constrained by conventional manufacturing limitations, precision engineering requirements, and industrial bottlenecks that prevented massive aviation expansion. German aviation planners calculated that Allied fighter production would require decades to match German technological capabilities while maintaining acceptable combat performance standards through traditional manufacturing methods. Strategic doctrine that incorporated German aviation advantages, assumed technological superiority, would enable continued air dominance through superior aircraft performance and systematic pilot training. Democratic air forces could allegedly never achieve rapid expansion and quantity-focused production approaches while maintaining individual fighter excellence that characterized German aviation superiority through precision engineering and professional pilot development. Economic calculations performed by German aviation economists revealed Allied industrial capacity divided between civilian aircraft production and limited military requirements, suggesting resource constraints that prevented total conversion to advanced fighter manufacturing. Aluminum allocation and skilled aviation technicians appeared insufficient for massive fighter production programs, requiring specialized engineering and precision manufacturing techniques. Cultural assumptions about American aviation, industrial organizations suggested inefficient production methods and profit-motivated, rather than strategically focused approaches that would prevent systematic advanced fighter manufacturing. German aviation ideology characterized democratic industry as wasteful and disorganized compared to German systematic efficiency and specialized aviation technological discipline that prioritized individual aircraft quality. Combat statistics from 1939 to 1943 seem to validate German assumptions about aviation warfare effectiveness and technological advantages over Allied air forces worldwide. German fighter units had achieved remarkable success through superior aircraft performance and systematic pilot training that appeared impossible for mass-produced enemy fighters to match through quantity alone. Aviation philosophy that German air forces emphasized included individual aircraft excellence, pilot proficiency development, and systematic combat experience accumulation that created elite aviation units through rigorous selection and professional advancement. German fighter forces prioritized quality over quantity in both aircraft and personnel, reflecting confidence that superior individual performance would achieve aerial victory through technological and training advantages. William Knudsen, former General Motors president turned director of production for the War Production Board, walked through the sprawling Republic aviation facilities, observing revolutionary production techniques that would transform fighter aircraft manufacturing through automotive mass production methods adapted for aviation warfare. The civilian industrial executive was applying innovative production expertise to sophisticated fighter construction with systematic efficiency that would fundamentally challenge German assumptions about aviation manufacturing limitations. The P-47 Thunderbolt program that American industry developed represented complete departure from traditional fighter aircraft manufacturing that emphasized individual craftsmanship over systematic mass production for aviation operations. Thunderbolt design prioritized combat reliability, pilot safety, and assembly line production capability rather than technological sophistication alone, enabling manufacturing rates that completely exceeded German aviation industrial calculations and strategic planning assumptions. Assembly line techniques that Republic Aviation employed included revolutionary automotive production methods systematically adapted for complex fighter manufacturing through organized workflow, standardized components, and continuous production that eliminated traditional aviation manufacturing bottlenecks. American industrial experience had created unprecedented manufacturing efficiency that surpassed specialized fighter production through civilian innovation applied to military aviation engineering. Workforce mobilization supporting fighter production included revolutionary numbers of women entering precision manufacturing while maintaining comprehensive training programs that created skilled workers adequate for complex aircraft assembly operations. Democratic educational systems produced abundant human resources through competitive instruction, merit-based advancement, and systematic aviation manufacturing skills development that exceeded traditional fighter production workforce limitations. Supply chain coordination across American fighter manufacturing included specialized aluminum delivery from multiple continental sources, engines from dedicated manufacturers, and thousands of precision components from hundreds of subcontractors whose production was synchronized through systematic logistics management. Materials coordination exceeded German organizational capabilities through democratic industrial cooperation and competitive resource allocation that enabled unprecedented fighter production rates. Quality control procedures ensured fighter reliability through systematic testing protocols, continuous inspection processes, and rigorous combat performance validation that maintained aviation effectiveness while enabling unprecedented mass production rates. American fighter manufacturing had achieved consistent quality through scientific methods rather than traditional individual craftsmanship attention, proving that systematic approaches could maintain aviation standards while enabling mass production. Innovation acceleration continued throughout fighter development as American engineers continuously improved aircraft specifications while maintaining aggressive production schedules that traditional methods could never sustain. Competitive pressure encouraged rapid advancement that exceeded conventional aviation development cycles while ensuring manufacturing compatibility and sustained production capability that traditional approaches could never achieve. Strategic planning that incorporated massive fighter deployment included comprehensive aviation tactical doctrine development and operational coordination that would maximize aircraft effectiveness across global theaters. American military aviation strategy integrated production advantages into comprehensive campaign planning that assumed virtually unlimited fighter availability and continuous replacement capability. Manufacturing excellence that fighter production achieved included combat reliability, pilot protection, and aviation effectiveness that exceeded traditional aircraft development while maintaining mass production compatibility. American industry had proven that systematic manufacturing could produce effective fighters without sacrificing performance, demonstrating democratic advantages in combining adequate technology with industrial abundance through competitive innovation. December 1944. German intelligence documentation of American fighter production revealed manufacturing statistics that challenged every fundamental assumption about aircraft construction and aviation. Industrial possibility worldwide. American factories were completing over 5,000 fighter aircraft monthly while maintaining simultaneous production across dozens of facilities that collectively exceeded total German aviation manufacturing capacity by incomprehensible margins that seemed mathematically impossible. Mathematical analysis that German aviation planners performed revealed American fighter production approaching 200,000 total units since Pearl Harbor, while German fighter aircraft production struggled to maintain 40,000 aircraft across all manufacturers and facilities. Enemy industrial capabilities had achieved systematic abundance that completely violated traditional assumptions about precision fighter manufacturing, complexity, and specialized aviation engineering requirements. Statistical verification through multiple intelligence sources confirmed American fighter production that included standardized components, revolutionary assembly line manufacturing, and systematic quality control that enabled mathematically impossible production rates for advanced aircraft. Enemy manufacturing had achieved unprecedented efficiency that exceeded German aviation industrial organization through democratic competitive methods and civilian automotive expertise applied to fighter manufacturing. Photographic reconnaissance of American aircraft factories revealed production techniques that completely eliminated individual aviation craftsmanship in favor of systematic manufacturing approaches directly adapted from civilian automotive industry methods for fighter applications. Democratic Aviation Industrial Organization had achieved military production through competitive rather than centralized authoritarian methods and systematic resource optimization. Economic calculations demonstrated American fighter expenditure that exceeded entire German aviation budgets, while simultaneously maintaining civilian aircraft production and comprehensive international assistance programs. Democratic capitalism had achieved resource abundance that centralized command economy methods could never duplicate through systematic efficiency and competitive innovation in fighter manufacturing that rendered German economic assumptions obsolete. Supply chain analysis revealed American fighter manufacturing coordinated across continental distances, with material flows that dramatically exceeded German logistical capabilities and organizational systems. Enemy industrial organization demonstrated systematic coordination that exceeded authoritarian central planning through competitive cooperation and democratic resource allocation methods in aviation production that achieved efficiency through civilian expertise. Technology assessment based on captured American fighter aircraft revealed manufacturing quality that maintained combat effectiveness while being produced in quantities that German industry considered physically impossible without sacrificing performance specifications. Mass production had achieved consistent reliability through systematic scientific methods rather than individual attention and artisanal approaches that characterized German fighter manufacturing philosophy. Performance analysis of recovered American fighters demonstrated that mass production had achieved combat reliability, pilot safety, and aviation effectiveness that proved adequate for warfare while being manufactured at impossible scales. Systematic engineering had proven effective in producing functional fighters through competitive innovation and scientific manufacturing approaches rather than traditional craftsmanship. The statistical impossibility had become undeniable strategic reality that forced German acknowledgement of democratic advantages in aviation industrial organization that exceeded authoritarian alternatives through competitive efficiency and systematic abundance in fighter production that would fundamentally alter aerial warfare through industrial superiority rather than individual technological excellence. March 1945. The massive Allied fighter formations appearing over German airspace revealed devastating effectiveness of American aircraft production as over 8,000 fighters provided daily air cover while maintaining strategic reserves that exceeded German total aviation inventory. The mathematical superiority of American manufacturing had translated into overwhelming aerial dominance that rendered German aviation philosophy strategically obsolete through systematic fighter abundance rather than individual aircraft excellence. Tactical deployment that American fighter abundance enabled included multiple aviation groups operating simultaneously across European airspace while maintaining air superiority capabilities that German interceptors could never counter, despite individual aircraft superiority and pilot training advantages. American production had eliminated traditional aviation constraints through systematic abundance and continuous aircraft replacement that exceeded conventional aerial warfare limitations. German fighter pilots discovered combat situations where shooting down individual American fighters achieved minimal strategic impact because American aviation strength exceeded German interception capabilities through numerical abundance. Mathematical relationships had shifted decisively toward Allied air forces through manufacturing capacity rather than individual combat effectiveness or pilot excellence that had characterized traditional aviation warfare approaches. Combat statistics from sustained European air operations documented German fighter losses that could not be replaced, while American aviation units maintained operational strength through continuous production and systematic pilot replacement programs. Industrial abundance had created tactical sustainability that exceeded German response possibilities and resource allocation capabilities through democratic aviation organization. Intelligence analysis by German aviation commands revealed American production capabilities that dramatically exceeded strategic planning assumptions, while demonstrating aviation organization that surpassed authoritarian efficiency through democratic competitive methods. Enemy capabilities had achieved systematic advantages that traditional military aviation could not anticipate or counter effectively through conventional fighter tactics. Psychological impact on German fighter pilots included recognition that individual combat excellence could not influence strategic outcomes when facing opponents with unlimited aircraft capabilities and continuous reinforcement deployment. Tactical aerial victory had become strategically meaningless against American production abundance and systematic fighter deployment that exceeded traditional aviation warfare mathematics. Operational advantages that American fighter production provided included aircraft availability, pilot replacement, and sustained mission capability that maintained air superiority under extended campaigns across multiple theaters. Systematic aviation operations exceeded German capabilities despite homeland air defense advantages and theoretically superior interior coordination lines. Air superiority capabilities that fighter abundance enabled included sustained patrol operations, continuous bomber escort, and aviation support availability that German air forces could never counter through individual excellence. American production had created operational sustainability that exceeded traditional aviation limitations through systematic abundance and technological adequacy. The fighter swarms over Europe demonstrated American aircraft production had fundamentally altered aerial warfare mathematics through manufacturing capabilities that rendered traditional aviation excellence obsolete when facing systematic abundance, combined with adequate performance and continuous aircraft replacement capability that exceeded conventional aviation limitations. May 8, 1945. As Nazi Germany surrendered unconditionally following complete Allied air superiority, the final accounting of American fighter production revealed numbers that had redefined aerial warfare. Over 200,000 fighter aircraft manufactured through revolutionary assembly line methods that averaged 140 completed fighters daily at peak production, creating aviation capabilities that had overwhelmed German Air Force excellence through unprecedented systematic abundance and continuous replacement. Strategic validation that American fighter production provided confirmed industrial mobilization as the decisive factor in modern aerial warfare, while demonstrating democratic advantages in manufacturing organization, resource allocation, and technological application that exceeded totalitarian alternatives through competitive innovation and systematic efficiency optimization. Democratic aviation industrial organization had proven superior to authoritarian approaches through mathematical evidence that could not be disputed. Hermann Göring's post-war acknowledgement included recognition that German aviation superiority had been strategically defeated by American production capabilities that exceeded every calculation of democratic industrial potential and fighter manufacturing capacity. Assembly line manufacturing had rendered individual aircraft excellence and pilot skills strategically irrelevant through overwhelming numerical superiority and coordinated aviation deployment that exceeded traditional aerial warfare approaches. Economic efficiency that American fighter production achieved included dramatic cost reduction through volume manufacturing while maintaining combat effectiveness that exceeded traditional aircraft development methods. Competitive capitalism had proven systematically superior to command economy organization for sustained fighter production and technological advancement across global aviation operations through democratic resource allocation and competitive innovation processes. International cooperation through American fighter deployment included comprehensive aircraft transfers to Allied air forces that enhanced collective aviation capabilities while demonstrating American production capacity far beyond domestic requirements. Democratic values had created sustainable assistance through systematic fighter sharing and strategic generosity programs that exceeded traditional military alliance approaches through competitive manufacturing. Technological legacy of American fighter production influenced post-war aviation through revolutionary manufacturing techniques, systematic design principles, and scientific quality control methods that transformed global aircraft production standards. Scientific advancement had created lasting advantages through systematic research and competitive innovation processes that exceeded traditional aviation approaches through civilian automotive expertise applied to military aircraft. Training systems that fighter abundance enabled included accelerated instruction programs, adequate aircraft availability for pilot training, and systematic aviation development that created human resources sufficient for expanded Air Force capabilities. American military aviation education had produced fighter pilots through competitive instruction and merit-based advancement that exceeded traditional elite development approaches. Manufacturing innovation that enabled American fighter success demonstrated democratic society's ability to coordinate massive aviation resources through systematic planning and competitive efficiency rather than authoritarian control. Democratic systems had produced fighter capabilities that exceeded totalitarian alternatives through systematic coordination, competitive innovation, and merit-based operational advancement that proved democratic advantages. The aviation triumph had proven that democratic industrial organization could achieve systematic advantages over traditional Air Force excellence through competitive innovation, systematic manufacturing, and abundant production that totalitarian aviation systems could never match through centralized control, individual craftsmanship, or authoritarian resource allocation alone in fighter manufacturing and aerial warfare. If this incredible story of how American assembly line fighter production overwhelmed German aviation excellence through systematic abundance amazed you, make sure to subscribe for more tales of democratic aviation triumph.